Q5609. Unless adjusted, the fuel/air mixture becomes richer with an increase in altitude because the amount of fuel A. decreases while the volume of air decreases. B. remains constant while the volume of air decreases. C. remains constant while the density of air decreases. The correct answer is C. Unless adjusted, the fuel/air mixture becomes richer with an increase in altitude because the amount of fuel remains constant while the density of air decreases. As an aircraft climbs to higher altitudes, the atmospheric pressure decreases, which results in a lower air density. The carburetor, which mixes fuel and air before it enters the engine, will receive air that is less dense. Since the amount of fuel remains constant and the density of air decreases, the fuel/air ratio becomes richer. This means there is a higher proportion of fuel relative to the reduced density of air. Without adjusting the mixture, the engine may run richer than optimal at higher altitudes, leading to decreased engine performance, fouled spark plugs, and potential engine damage. 5610. The basic purpose of adjusting the fuel/air mixture control at altitude is to A. decrease the fuel flow to compensate for decreased air density. B. decrease the amount of fuel in the mixture to compensate for decreased air density. C. increase the amount of fuel in the mixture to compensate for the decrease in pressure and density of the air. The correct answer is A. The basic purpose of adjusting the fuel/air mixture control at altitude is to decrease the fuel flow to compensate for the decreased air density. As an aircraft climbs to higher altitudes, the atmospheric pressure decreases, resulting in a lower air density. The carburetor, which mixes fuel and air before it enters the engine, needs to adjust the fuel flow to maintain the proper fuel/air ratio. By decreasing the fuel flow, the mixture control compensates for the reduced air density and ensures that the air/fuel mixture remains within the desired range for optimal engine performance. This adjustment helps prevent the mixture from becoming excessively rich, which can lead to decreased engine performance, fouled spark plugs, and potential engine damage. 5611. At high altitudes, an excessively rich mixture will cause the A. engine to overheat. B. fouling of spark plugs. C. engine to operate smoother even though fuel consumption is increased. The correct answer is B. At high altitudes, an excessively rich mixture will cause the fouling of spark plugs. When the mixture is too rich, there is an excess amount of fuel compared to the available air. This can result in incomplete combustion and the buildup of carbon deposits on the spark plugs. Fouled spark plugs can lead to misfires, reduced engine performance, and difficulty in starting the engine. The excess fuel can also contribute to the formation of carbon deposits in the combustion chamber and on other engine components, which can further impact engine efficiency and performance. 5170. Leaving the carburetor heat on while taking off? A. leans the mixture for more power on takeoff. B. will decrease the takeoff distance. C. will increase the ground roll. The correct answer is C. Leaving the carburetor heat on while taking off will increase the ground roll. The purpose of the carburetor heat is to prevent the formation of ice within the carburetor by directing warm air to it. This is important during flight in certain weather conditions. However, during takeoff, the carburetor heat should typically be off. The reason for this is that the warm air from the carburetor heat can decrease the air density and reduce engine power output. This reduction in power can result in a longer ground roll before the aircraft reaches its desired takeoff speed. 5189. Which statement is true concerning the effect of the application of carburetor heat? A. It enriches the fuel/air mixture. B. It leans the fuel/air mixture. C. It has no effect on the fuel/air mixture. The correct answer is A. The application of carburetor heat enriches the fuel/air mixture. Carburetor heat is used to prevent the formation of ice within the carburetor by introducing warm air into the incoming airstream. This warm air helps to melt any ice or frost that may have accumulated in the carburetor. When carburetor heat is applied, the warm air mixes with the incoming air, increasing its temperature. The increase in temperature reduces the air density, causing a relatively higher proportion of fuel compared to the reduced volume of air. This results in a richer fuel/air mixture, as more fuel is mixed with the warm air.